Today's program is being recorded. Any views expressed in this webinar are for general educational purposes only and do not represent any official views or positions of the sponsoring or presenters organizations. We are looking forward to your questions at the end of the program. Please submit them using the Q&A section. Greetings and welcome to today's educational program. In the webinar series of Preparing for Process Analysis, this is webinar number 5, Excellence in Data Visualization by Sandy Furterer and Doug Wood. This is your moderator, Shobha Mittal with ASQ Quality Management Division. Today we have the distinct pleasure of hearing from Sandy and Doug. Please join me in welcoming them. Dr. Sandy Furterer is a professor of practice at The Ohio State University in the Department of Integrated Systems Engineering. She has applied Lean Six Sigma, systems engineering, and engineering management tools in healthcare and other service industries. She previously managed the Enterprise Performance Excellence Center in a healthcare system. Dr. Furterer received her PhD in industrial engineering with a specialization in quality engineering from the University of Central Florida in 2004. She received an MBA from Xavier University and a Bachelor and Master's of Science in Industrial and Systems Engineering from The Ohio State University. She is an ASQ certified Six Sigma Black Belt, certified manager of quality and organizational excellence, certified quality engineer, an ASQ fellow, and a certified Six Sigma Master Black Belt. Coming to Doug Wood, Mr. Wood has worked over 40 years in the areas of cost of quality, office waste, root cause analysis, performance measurement. He has also helped others with various ASQ certifications in the quality auditing, management, and engineering. He has taught audit, Lean, Six Sigma, cost of quality, statistics, and failures, modes, and effects analysis. He has 4 ASQ certifications, CQE, CQA, SSBB, and CMQOE. Doug Wood has 3 publications by ASQ Quality Press, and these are the Certified Manager of Quality Organizational Excellence Handbook, 5th edition. This was also co-edited by Sandy. The Executive Guide to Understanding and Implementing Quality Cost Programs, Reduce Operating Expenses and Increase Revenue. And the third one is Principles of Quality Cost, Financial Measures for Strategic Implementation of Quality Management, 4th edition. His firm, DC Wood Consulting, LLC, has worked with clients in manufacturing, healthcare, and transactional businesses. The company website is www.dcwoodconsulting.com. And so, without further ado, it is my pleasure to introduce Sandy Furterer and Doug Wood. Sandy and Doug, the floor is yours.
Thank you, Shobha. All right, well, welcome everyone. Thanks for joining us this evening. We've got a variety of different weather conditions out there from what I've heard, just kind of aligned with our data visualization concept. Some of you would be outliers from a temperature and snow perspective, and others would be right in the middle there with us. So it's about 60 here in Columbus, Ohio. So we'll get started. I'll do about the first half, and then Doug will join us, and then Shobha will wrap up and let us know what other webinars are out there. So this is our 5th webinar, and we've had them pretty well connected as far as kind of the data we're showing and the concepts that we believe are most useful out of the CQPA handbook. So what we're going to do today is we're really going to look at how you can visualize data. It's a really critical part of data analysis. We've always thought of, just getting the data into the database, crunching our descriptive statistics, maybe doing some hypothesis tests are kind of the end all be all and where it all is. But really, trying to translate that data into a story, into helping people make decisions upon it is really super critical. And that's where this data visualization comes in. My son is in the PhD program here at Ohio State in Industrial Systems Engineering or Integrated Systems Engineering. And I asked him if he wanted to come to the webinar And actually, I live with him, so he's probably hearing it. But he said, "Oh, I've got class. It's on my visualization class." And I'm like, "Oh, very nice. So you're taking a class on visualization," and he's doing Tableau and all this stuff. So I should have invited him over to as the resident expert. But it's really critical as big data and data analytics gets more important. It's really super important. So we looked last time at the data analysis lifecycle, where you really have to spend a lot of time, just as in any type of project, and where you're going to do analysis in the planning function, in the creation function, really planning what you're going to collect, creating all the structures for collecting, all the definitions, and then plan how you're going to actually collect that data and how you're going to look at that data. An important part of really understanding that data, there's a lot of visualization to that, looking at the distribution of your data, looking for those outliers, understanding how best to represent that to tell your story. So these are, and then really the analyzing and visualizing then come out of all that good planning up ahead. So we're going to start with some simple data plotting. We're going to look at some very simple Excel tools where we can look at spider charts and Pareto diagrams, run and control charts, and some other ones. And then we're going to talk about when do you use which chart and what do you use it for. And there are some pros and cons. And of course, you know, things have to be attractive when you're looking at this visualization. They have to really speak to people, that people have to want to look at that chart. You can get drawn in differently by different charts. And then Doug will be able to talk about the ascent principles a little bit further on down the road. So here's our data analysis lifecycle. Again, kind of a nice graphic there. And we've talked a little bit about, in our past seminars, about the plan, creating, collecting, validating. Now we're really getting into where we get our data, and then we are starting to validate that data, analyzing, and then of course visualizing. And it's really not just a straight line. There's a lot of going back in this cycle, and maybe we forgot data, or maybe we don't understand what those fields on that data mean. We can go back and redefine it, redefine our understanding of that data, and then kind of keep circling back around. So this graphic I took from a Facebook, actually. Somebody had posted it because they liked it, and I thought it was pretty cool. And so it really shows kind of the evolution of data, where you start with this mess of Legos. Boy, do I remember those. I don't hardly ever remember seeing them sorted. I just remember the data. I don't think in my house we got much past the Lego data. But you know, you could sort these into categories. We do a lot of that in our manufacturing and our service environments, where we put things into buckets, different types of defects, different types of products, different types of industries, whatever it might be, some type of organization. Maybe it's different types of demographics of customers. And so we kind of start sorting things, and then we can arrange things to help us to make a little more sense out of them, and then present them visually. And doesn't that look like a histogram up there? And then, of course, if we can get to the point where we really can explain things and with a story, really help people to understand what decisions we're trying to make from this data. So why do we even care about this? Because really, we spend a lot of time in our work lives as quality experts, really seeing a lot of data, seeing the impact of a lot of data, making decisions upon this data. And as we get more and more data with the Internet of Things, with digital transformation, with being able to pull all of that data off of all of our pieces of equipment and machines, and trying to connect all of our systems, our enterprise relationship planning systems, with our shop floor systems, with our engineering design systems, now with a lot of the prototyping and simulating we do right in electronic means, we're going to have a lot of data. And so it's really important to understand where that data is coming from and how we can make sense of it. So that's really the importance of of why visualization is so critical. So let's start with some simple data plotting. So what I always tell my students is whenever you get data, first thing you want to do is make a graph of it in some way, shape, or form. Usually if it's, variable data, I'll throw it into a histogram. And if it's some type of categorical data, maybe into a bar chart or a Pareto chart, if there's some type of order to that. And so it's really also critical to look at your data, how it's acting over time, which is what a run chart gives us. So these aspects will help us to better understand the process. I was always pretty amazed at when I would start looking at data when I was involved in process improvement, especially hospital examples stick in my mind because they really do have a lot of data, but it's a lot of non kind of connected data. The emergency department doesn't necessarily see the inpatient data, doesn't see the outpatient data, doesn't see the surgical data, and they're really in silos of data. And so they do connect to each other from a patient going maybe from the emergency department to inpatient to surgery, back to the inpatient floor and so forth. But they really aren't connected from a flow perspective. They're usually siloed systems. So helping to understand the process is why we want to look at our data. And I've always, like I said, been amazed because it really tells that story. And I may not know the process as well as people who have been entrenched in the emergency department or in surgery for many years helping patients, but I can show visually show the data to others and they'll go, oh yeah, I know exactly why we have those outliers, because the patients wait for a long time in the emergency department to get transferred to a rehab facility or to get, maybe they're here a long time for observation for 24 hours or so, waiting on insurance or whatever it might be, but they can really tell you what that data means. And if I can share that data in a way that they can understand it, then we can all learn a lot more about that process. So let's look at the run chart. So you notice we've just got this graphic of this metric over time. This happened to be in the surgical suite. Whoops, trying to move. Oh, that's all right. Okay. Of the surgical suite of the wheels in to the wheels out. So what they usually measured was when the patient was wheeled into the operating room and to when they actually were complete. And then there was another, it was kind of the cycle of then wheels out. How long did it take before the next patient got wheeled in? How long did it take to clean that surgical room, to prep it, to bring in all the instruments and so forth. So this is what they looked at, and you can see there's a lot of that natural variation. Is it natural, or are there things like we've got circled up here? Is that starting to become an outlier? Is something happening? Was a patient very late? Did they have a problem where they needed an extra test or something? Somebody might have crashed, all that kind of stuff. So we can see these outliers, and then what we want to start doing is investigating. Are they really outliers? Are there any cycles in this data? So spikes, that might be a spike. Is it or not? Our statistics and our analysis can help us, but the first thing we need to do is to show this this graph, and it's very, very powerful because we can see our spikes. We can see what happens over time. We can see some shifts. Is the process shifting? It kind of looks like it might be, the time might be decreasing there a little bit over time. Certainly might have gone down for a bit, went back up maybe. Is it starting to have a trend where it's trending back up? It seemed to maybe be trending down. Is it trending back up? Is that a run? Usually runs are about 7 to 9 points. Maybe that could be the start of a run. And we would want to collect more data. Maybe it really doesn't look like a run because we collected too few points, and we really need to be collecting every point or more often in our process. So there's a lot of what you think about when you're starting to visualize this data. And then I love the graphs that help us to see outliers. I worked with just a wonderful process analyst when I was in healthcare, and she's gone on to be this huge VP at a healthcare system, and done really well. And she was the best at looking at data and visualizing data and understanding that process story from data. And we always debated. I always liked creating histograms, and she always liked creating box plots for some reason. And we certainly had our preference, which was kind of funny. But both of those really can show outliers very easily. So you can see this orange dot is getting kind of far from everybody else over there on the left. What's happening here? And so we can start to understand what's going on. And the asterisks in a box plot, you can see the same types of behaviors. And it's kind of what your users are used to looking at, what maybe your preferences as well. But there's a lot of charts that can do a lot of different, can provide you the same information in a different way. Here's a process capability calculations sheet. So we put specifications on this one, so we can see whether our process is capable of achieving these specifications. And so we can see our spread of our data. We can see if we have kind of weird shapes. Look at that. It kind of looks like a normal distribution, but then it's kind of also cut off there at the ends. We're not seeing things kind of out in our tails like we're used to. This almost looks like somebody took the data and said, I'm going to chop off everything before 3 and then kind of after 10. And you can tell a lot from that too. You can a lot of times not know much about the data, but know from this visualization that something strange is happening. And then these good old bimodal types of graphs where they are combining distributions. Really kind of common is to combine shifts of data. So we know when the supervisors and managers leave at the end of the first shift, that we don't necessarily know that what goes on, or things may be a little bit more relaxed, or maybe things are more productive as well, because people aren't being called out and into meetings and so forth. So we a lot of times will see these bimodal distributions because we combine data on the same process, the same machine, but with different shifts. We see this was easily a representation of the emergency services data, where you had patients that were discharged from the process that weren't as acutely ill versus patients who were very ill who got sent to, who got admitted to the hospital or had to go directly into surgery. You can have multiple distributions, and you really got to think through, am I going to combine all that data, or am I going to separate it out into different histograms? And usually when this happens, you'll want to separate those out because you've got two different processes going on, and you really want to dig in deeper to understand that. So the histogram is probably one of the most powerful tools from that perspective, or dare I say, the box plot. So let's go through just a few other of the tools that we have. There's lots of great tools in Excel. And I think Doug's very similar to myself, where I bounce back and forth from a statistical tool to Excel, depending upon the type of chart I might want. Excel has really gotten a lot of different charts. Sometimes I'll just play with a lot of different charts. There's starting to be a lot more visualization tools. You can do visualization tools, I might add, not as pretty as Excel, in Python. There's a lot there. Takes a lot longer to get to than throwing it onto Minitab, but there's reasons for wanting to there's things that Python can do that you might not be able to do in other tools. So again, thinking about where you're gonna do your visualization, what tool's gonna be the best for you. There's more tools coming on every day because this is becoming so important with all the data that we're getting. Oh, do I want to say anything else about that? I think we've got some other examples in a little bit further. I think this is almost where I'm handing off to Doug. This is just an example where we took a very nice application of our data, pulling it into Excel, and then creating a nice dashboard to visualize where we had alerts in our process. This was actually shown up on the monitors throughout the entire process area. This is actually for, I'm sorry, this is an emergency department. We had one there too. This is for the interventional radiology procedure area. And this was looking across each bed and looking at the status of where the patient was in the process for each room. And then looking at the steps of the process and knowing, hey, that first bed, they came in, they left. The fourth one, they came in and they're trying to leave, but they're waiting for a room. And so the Excel is able to visualize this through a dashboard that everybody can look out there and say, hey, let's go attend to the patient in room 2 because they've been waiting for lab results for a long time. So this is really powerful to combine your ability to pull in data real time and then show this in a dashboard. So Doug, would you like to jump in with the spider chart?
Certainly, if you'll continue to move the slides.
I will.
There was a question a minute ago about data visualizations for qualitative data. And that last one was a good one of that, okay? Because those were qualities, those were categories. There weren't numbers associated with that. So the spider chart is another tool that is available in Excel. And not a lot of people use it, but the idea behind this is that you've got these categories, okay? You see them around the outside, and then what we're trying to do here is to show how to each category refer to. Now you can see here there's a value that's being counted, right? And the value is how far you are from 0, so how far you are from the middle. And then you can quickly see, well, look, it's all special imaging studies, okay? There's hardly any of the other ones, and that makes it very, very clear. Okay, you can include more than one set of numeric values. This makes a different colored line, so you can have different colored lines on this. This is only showing one value, okay? So that would be helpful. Just remember that if you have too many lines, it gets confusing. Stick to the story you want to tell. Next. So the Pareto principle is also called the 80-20 rule. We've all heard that, okay? To make this, what you do is you count what's happening, and you take the counts, and you sort them from the largest count to the smallest count. Those are the blue bars at the bottom. And then you accumulate those values, and you plot them on the right-hand side. So the left-hand side is just the count. That's the height of the blue bars. And then the right-hand side shows you what percentage you've accumulated to that point. So the first 2 blue bars, okay, they total, see that little dot above the second blue bar? That accounts for almost 50%. Those 2 account for almost 50% of the total. So the idea is that it shows the important few and the trivial many. It will also communicate, why did you focus on those few areas? And it's obvious. You look at this and you're like, yeah, we're not going to worry about those little ones, okay? When the cumulative line goes flat, you've reached the point of diminishing returns. And that's what that cumulative line helps you see. Next one, Sandy. So if you have 2 variables that are on numeric scales, you can plot them in a scatter plot like this. And I realize this is maybe a little fuzzy, but that's okay. Don't worry. You don't have to worry about the numbers. You're going to show how each one changes as the other changes. Okay. this particular plot shows when the bottom one goes up, the left-hand side goes up. When one goes up, the other goes up. That would be a positive correlation. Okay. Correlation is then a calculation off of all these dots. Okay. But there's something very important to remember. When you show someone one of these plots, you need to always say the correlation does not mean cause and effect. You have to say that. Because you know what? They're going to think that. Next, Sandy. So sometimes we don't have numeric data. All we have are, well, we have numeric data, but it comes in buckets. Okay. So here we have marketing campaign results for, multiple cities. And we have 3 brands. Those are buckets. But what kind of results are we getting? Okay, so the height of the bars represents that. Bar charts allow comparison of relative values. What's important on a bar chart graph is you need to stack the bars next to each other in a meaningful way to make your key points. You see, we've got 3 brands in each city. You could have stacked this and you could have put brand A with all 6 cities and then another brand B with all 6 cities. But is that going to tell the story you want? You need to think about, what are you explaining? What's important here? This particular chart gives you a real good handle on how well is each city performing with a brand compared to the other ones. Next, please. Okay, this is not what we mean by a pie chart. Okay? It kind of looks like a pie chart. This is what we mean by a pie chart. Now, if you use a pie chart, it is to show parts of the whole. That's about it. If you try to do other things with it, you're going to confuse people. Like if you want to compare last year to this year and you give them 2 pie charts, that's not going to work. It's very difficult to compare wedges from one time period to another. When you do a pie chart, do not do what we did here. Okay? You see, there are numbers around, but we're not telling you what those numbers represent on the pie chart. You've got, 4 different colors here. Is that quarters? Is that years? I don't know. So you need to label the wedges on the pie chart. Next one. Now, Excel does miss some charts. Control charts are not easily made in Excel. You can make them, but yeah, it's kind of difficult. You want a control chart. I would suggest, something like Minitab, because Minitab is built for control charts. A bubble chart is another kind of tool that can be used, and Excel does not really do bubble charts. But let's go to the next slide. So this is a control chart. You see the run chart is on the left. We saw that one a minute ago. A control chart is sort of like a run chart in that it shows its time is going across the bottom. But what we're doing on a control chart is we're plotting 2 different things. Whereas the run chart just counts the level, the value, the height. On a control chart, you take a sample and the top you plot the averages of each sample. So each of those dots represents a sample, 4, 6 or so. In this case, it's not actually a sample, it's individual data points. So it's just like a run chart at the top. But the bottom half of the control chart, that represents the change from one point to the next one. So the bottom is telling you about the variability, and the top one is telling you about the level. And if you think about that, things can go out of control based on level, or they can go out of control based on variability. Okay, next slide. Bubble charts are another flavor altogether. And these particular ones come from the Swedish statistician Hans Röbling, who passed away a couple of years ago. There's his website on there, gapminder.org. And you can draw these charts. What they have done there, it's amazing. They have this is the graphical representation. Let me explain this. Number one, first of all, the horizontal and the vertical axes are chosen from 100 different measurements. You see, this one talks about life expectancy, and it's plotting it against income. But there's 100 different choices you can make there. Now, the population size is the size of the bubble, the balloon size. Okay. The year is determined by a slider across the bottom that you can't see here. The current year is 2021. And so as you slide the slider back and forth, the bubbles all move up and down and they change size. The visualization power behind this is amazing. Oh, besides that, the color of the bubble represents the continent that those countries are in. I bet you can guess what the two large red circles are, right? So the point here is you can show a lot of data with a chart like this. It's very powerful. Okay, next slide. So just remember, pie charts do not show change over time. Pie charts are only intended to show parts of the whole. Using them to show change over time is the wrong way. A bar chart allows comparisons of size when next to each other. How one value drives the other values is not visible. So bar charts are hard to see correlations. A bimodal histogram, like we saw a few minutes ago, that means you have mixed data. Two things are occurring and the data is jumbled together. A run chart is just going to show ups and downs. You won't be able to see two averages on a run chart. So if you have mixed data, a run chart is not a good tool. So what are you trying to say? You want to remember that most viewers will only remember three points you're trying to make. Make your points. Choose your charts wisely. Next slide. So one of the masters of presentation of information is Edward Tufte. His book, The Visual Display of Quantitative Information, is absolutely an encyclopedia of this. First of all, focus on the points being made by the data. You need to serve a reasonably clear purpose. You need to, are you describing, are you exploring, are you tabulating, or are you just decorating? What is the story to tell about the data? You saw that first slide with the Legos. What's the story? Secondly, Tufte calls it the lie factor. The graphic images might not be equal to the effect that the data has. This is when people do three-dimensional plots, this is often a problem. Third, he says, provide several levels of context, okay? Use words, use numbers, use drawings. Have little messages to explain the data, like a leader line coming off of a chart and have some text out there to say, this is what happened here. He recommends not using legends. This is the default in most software. It builds a little legend off to the side. If you put labels on the graphic itself, no legend is required. Also, you want to make sure that you have equal time periods. If you're comparing last year to this year, they've got to be a whole year. If you're comparing 6 months to 6 months, make sure they're equal time periods. Otherwise, it gets very confusing. And point number 4, you need to be careful of your color choice. Number 1, certain colors jump off the page at people. Red, for example. But remember, there are people who are color deficient. 5 to 10% of the viewers will have trouble with red and green. So maybe you need to use blue and orange instead of red and green. Next slide, please. So the accent principles, you'll see we reference in our references at the end of the talk where this comes from. The accent principles for effective graphical display are some others. This is not from Edward Tufte. This is another source. First of all, apprehension. The ability to correctly perceive relations among variables. Does the graph maximize the apprehension of the relations among the variables? This next one, C. The ability to visually distinguish all the elements of a graph. Are the most important elements or relations prominent or not? Consistency. Can people interpret the graph based on the similarity to previous graphs? So if you're going to do a series of graphs, they should look similar so that people can interpret them quickly. The next one is efficiency. You need to be able to portray complex relations as simply as possible. Sometimes it's a matter of choosing the axes or twisting things around in order to be efficient. Are the elements of the graph economically used? Are you using, the right sizes of lines and thicknesses and dots on it? And is the graph easy to interpret? There's something I learned. I was working with Boeing Company, and something that they had done for years is every graph had an arrow on it, and it pointed in the direction of good. Okay? Often it would say the word good with an arrow, or that up or down, allowing people to quickly interpret what it was saying. Okay, necessity. What's the need for the graph? What are you doing with it? Is the graph more useful compared to a table, or maybe just explaining something? Are the graph elements all necessary to convey the relations? And finally, truthfulness. This is the ability to determine the true value represented by any graphical element by its magnitude relative to an implicit scale. If something is magnified bigger than it should be, it's going to look out of proportion. Next slide. So, in conclusion, there's so much to planning and creating and collecting and validating, analyzing and visualizing data. Our hope here was to provide you with some tools and ideas for enhancing your data analytics journey. We want to make sure that you think about your data presentation from the point of view of your audience. What do you want them to learn? And finally, here are some references. We realize that this presentation has been abbreviated. We've included some references here for you to look at and do further study. Presenting data takes some thought. We've given you some guidelines, and we hope that you've learned a couple of new things today. So this series was developed from the CQPA body of knowledge. Sandy mentioned at the beginning. The body of knowledge contains much more, but the series focuses on some of the more important areas. I would strongly recommend any of you who want to move into an analytical role to consider this as this certification from ASQ. And now I think we can hear from Shobha. Next slide. There's our contact information.
Well, thank you, Doug and Sandy, and we'll begin the Q&A here. And we have some questions coming up, and I'll read those to you. So first one is, are any type of run rules used to detect the abnormal data or change in the data?
Run rules. Sandy? You're muted, Sandy.
I was trying not to interrupt you. So I would use the run rules that are aligned to control charts. So it's typically, a run of 7 to 9 points up or going down are what I'm most familiar with. But you can look at like Minitab will show all the different tests that they do. And just from a run, it's usually that. It's usually that there's a probability that it's statistically a very low probability that those runs could be occurring randomly. And so there must be some change in your process or something that is going on that you can identify and assign a cause to if that is occurring. So that's what I usually use, is just the mini tab rules. One thing about it, though, you need to be careful. A lot of times you want to pick these patterns out yourself by looking at these versus having 5 different rules identifying and circling things, or identifying the dots in red or whatever, because you're increasing the probability of your errors than if you're adding too many rules on control charts. So I'd keep it real basic. When do points go outside of the control limits? And then you can look for your runs yourself, because even that run of 5 in that chart that we saw was starting to get suspicious. So you can kind of see those yourself and pick those out for yourself.
Thank you. So we have a wise thought which I would like to read, is without data, we just have an opinion, by the Pope Edward Deming. That was a nice thing. So moving on to our next question, do you have an example of where you used more than one data visualization at work or to solve a problem?
Yeah, I would say you kind of use the different tools, visualization tools, kind of in a sequence. Like I almost always start off with something that shows me the distribution from a central tendency, an average, or a median, and then the variation, the standard deviation in that chart. So the histogram's really good. I joked about the box plot, but that's a very good tool to use as well. And so that's the first thing I do when I have continuous data. And I try to understand the distribution and whether it follows a normal distribution or not. And then I might do something to put control limits around those. So then you might start with the run chart and then add control limits. You might run a control chart to assess stability of your process and then run process capability. And you'll get your histograms from a specification perspective there. And then you can start playing with things like the scatter plots when you start trying to understand if there are relationships between the data, like perhaps, well, I liked the chart that Doug showed as far as income and life expectancy. But in the emergency department, we were looking at things like age and, their acuity level. Were there relationships there? Were there relationships in the length of stay and how many tests that the patient had to take, and so on and so forth. So that then you start, kind of digging into the data deeper, and some of these charts start getting maybe a little more complex, or plots not too complex. Then you might do something where you're trying to get a relationship of several factors through a linear or multiple regressions. So then you might go more in depth. You could then get into design of experiments, analysis of variance, where you might be looking again at histograms. You might be looking at linear regression models again. You might be looking at the factorial plots. These all serve a great purpose when you're digging into the data from an experimental design perspective, trying to understand the factors and the levels of the factors, how it impacts your quality characteristic. So I usually start histogram and then just kind of start digging in and go to things that show more relationships then.
My to do, if I have attribute data, it's just buckets. Okay. I would probably start with some kind of a bar chart. Maybe a Pareto chart. Okay. If I had a lot of buckets. Okay. And then from there, I might break that down in different time buckets. Okay. So this is what it was like month 1 through 6, and here's what it was like month 7 through 12. And is there a shift in the Pareto? Do I see 2 different sets of bar charts? Okay. I think we answered that, didn't we?
All right.
Yeah, that was good from a continuous and a attribute data. Great.
Mm-hmm.
Okay. Next question is, the majority of examples involve processes that are contingent on time, that is, services completed as TAT and explained in terms of manufacturing with shifts. But other services plotting data do not rely on time. In particular, testing services frequently plot box and viscous diagram to portray confidence intervals analysis for comparisons. What I struggle with is also conveying additional statistical analyses such as z-scores, t-stats, etc. Ideally, it would be useful to overlay those diagrams. So what are your thoughts on that?
Well, the in Minitab in particular, when you do a graphical analysis, it does have a histogram, but then it'll show you your confidence intervals. Usually, you select a 95% confidence interval around your mean, around your standard deviation, and maybe the median or something. I think they have 3 different confidence intervals. So that kind of starts to do both. That gives you an assessment of your distribution, whether it fits a normal distribution, and then what your confidence intervals are. So kind of connect into your statistical tests as well. Doug, did you have anything further on that?
We didn't show a lot of Minitab here because we wanted to make sure that this was for a variety of people, and everybody has Excel. Okay. And Sandy mentioned, Python and there's Tableau, there's a lot of other tools, but if you're involved in t-tests and z-scores and you're doing a lot of statistical comparisons and so on, it is highly valuable to have a statistical package like Minitab or Jump, because those they're so fast to do the analysis, and they will be right when they do the analysis. There are some add-ins that you can buy less expensively for Excel that will do some of these, but the add-ins don't always have the documentation behind them. When you look in Minitab and you go, well, what's that doing there? Okay, Minitab can give you a whole book of explanations as to what that means. Some of the other less expensive packages lack that. So if you're involved in that kind of stat work, you really need a stat pack. There's just no other way around it. You'll spin your wheels forever.
Okay. So we have another question which is referencing slide 29. And it's saying, avoiding distorting what the data shows. How do you manage biased data and the presentation / story influencing interpretation? For example, Daryl Huff wrote a book on how to lie with statistics. How do we manage when data collection goes too far?
Okay, lying, you've heard the phrase, there's, liars, there's damn liars, and then there's statisticians. That's kind of an expression of frustration. What Edward Tufte was talking about here was you need to make sure your charts don't lie. You want to make sure that you have some points you're making and you stick to those points. That was his thesis here in writing this book. If you want to know more about this, you need to get this book either from the library or purchase it. It's just full of examples, okay, of how, for example, he has a chart where people have they've created two-dimensional icons to represent the sizes of things, like a dollar sign, okay? And so it starts off small and then it gets bigger and bigger as it goes across the page. But the problem is the proportionality is the height of the dollar sign, not the square area of the dollar sign. And as it gets taller, it gets wider. And so therefore, it's expanding it squared, okay? And you can't compare the big one to the little one at all because you've distorted the data by using that two-dimensional icon. Did I answer the question?
I think you did. I think another aspect of that is to be careful of your axes because you can distort your data very easily. So say you've got a natural scale of your percent of defects. You or even time, you've got to think about how high that y-axis especially should go. And if you've got like 60% of my cases start on time in the surgery suite, and then I use a 65% scale, y-axis maximum scale, well, it's going to look like I'm doing pretty well. When really I've got 40% that aren't starting on time, I should probably put my axis up at 100%. So you just got to be really careful across graphs that are for the same purpose. You might have different pages and you might change your axes, and you just need to be careful, especially those kind of things. That's where I see that I can really distort the data pretty easily in a bad way if I'm not careful with that. And sometimes you're not even conscious about it because a lot of these programs will automatically select based on the data. And this may be the data you have today, but the data that you're trying to get to, that axis really should be something different. So that's one area that's important.
Excel used to automatically select the min and the max on a chart off the data. And they changed that a few years ago to where now it starts from 0. But it still automatically sets the maximum based on your data. So yeah, it's still a problem.
What has been your experience with Power BI? And the other is the semi-log and log scatter plots.
I have not had Power BI experience myself. Have you, Doug?
Oh, I've opened it a few times and I've worked with it a bit. There's a bit of a hurdle you have to overcome in terms of getting your mind around the controls of Power BI. Okay, Excel is easy because it's just a matrix, and everybody can look at that and know, oh, well, there's an up and a down on that one. But Power BI it uses multiple dimensions, and I can envision 2 dimensions. I can even envision 3 dimensions, but 4, 5, I can't picture 6 dimensions. And so it becomes harder to grasp what you're trying to do. That has been my experience with that. So yeah, it's a great tool, but you got to kind of swim in it and get really used to it. It's not something you're going to just dip your toe into and use briefly.
Yeah, and that's why I encourage going in steps, like I talked about. Just kind of start off with the exploration of your data and try several different views of your data. Run charts and putting maybe in a trend line and doing the histogram and then build up to those types of graphs. The other thing, it sounds more like Power BI might be for having very extensive, complex presentations or something pretty fancy, which is great, and it serves a purpose of telling a story. It's kind of, again, to the point of what Doug was saying of what is your purpose. And if I'm doing these graphs really to understand the data and to assess whether there are factors that are correlated or whatever, whether there are defects in my process, whether there's room for improvement, that's a very different story I'm trying to tell about my data versus if you're maybe trying to sell a new business plan off of, I think I'm going to get this much income next year, from the sale of my books or something like that, right?
Yep. Hopefully we
We'll
answered
just
that
take
one.
the final 2 questions now in the interest of time. So, with control charts, what is the best way to plot 2 sigma and 3 sigma from the current average in Excel?
Okay,
I
so
think Minitab has where you can change your control limits. You can change them to probability limits. You can change to 2 sigma limits. So there's a lot of functionality there where you can be changing your limits. I don't know if it has the ability to put both of them at the same time, like kind of like those zones that you'll see, but I'd have to play with that a little bit to see.
You can do anything in Excel. You just have to work at it. If you're going to do a lot of work with control charts, again, it's worth the money for a statistical package because it will allow you to quickly build your charts. Now, most data for Minitab starts out in Excel. People will pull it from a database, they'll stick it in Excel, and they have to clean it. Data in most databases is full of junk. And so if you try to put junk into a control chart, it'll be meaningless. So you need to make sure that your data is pretty clean. And Excel is a great visualization tool to clean data. But it's not that great when you're getting into more of these complex things. I hope we answered that one.
And I would just add, as far as control charts go, typically every time you run a control chart in Minitab with your data, it's updating the control limits. Traditionally, when you're supposed to be using your control charts, you usually collect, maybe 25 subgroup samples, and then you calculate your control charts, and then you run with those control limits for a while, unless there's some reason to change them. So that's one thing you need to be careful of. Minitab will lead you astray if you don't know really how to use the control charts. If you just want to graph them, that's one thing. But if you really want to use them and continue to know if your process is stable or if you've got a cause you need to assign some cause to, a point you need to assign a cause to, that's a difference of how you use those.
Okay. Very quickly, what is the most common mistake you see when developing data visualizations?
Probably not knowing the process behind the data.
This is where your subject matter experts, you plot the data and you show it to them. And you ask them, what do you see here? And they will sometimes just go, oh, well, yeah, of course. Or sometimes they'll say, I don't get that. And the subject matter experts have the expertise to interpret what the graph is saying. So yeah, you have to have the people around who know what's happening on the ground.
So we do have some more questions. Obviously, we cannot take them tonight, but please send them to Doug and Sandy directly, and they'll definitely respond to it. So let's go over the concluding slides very quickly. So our upcoming QMD webinars are, one is on 3/8, and this is the power of games to unleash collaboration and creativity in education by Zach Gerard. And then we have on 23rd of March coming up, the Africa Journey Laboratory Quality 2003 and to 2023 by Michael A. Noble. And then on April 4th, we have Future of Work in Education, Braided Solutions by Evelyn Van Til.
Hey, Shobha and Doug, are those times correct? Are they all central times?
Yes, I believe they are.
Yes, I think so too.
Okay, great. Thank you.
Next slide, please. So if you have not joined ASQ, please consider joining. It's a very good resource with very rich and current information. Next. And if you go under ASQ and My ASQ into the communities and you scroll down to Quality Management Division, you'll find many useful and pertinent information, including the recording of all the webinars that we host and other resourceful stuff. Next slide. And this is the end of tonight's webinar. Thank you all so much for tuning in. Have a great evening. Bye-bye.
Thank you.
Thank you.